Okay, so now we're looking at supply and demand. All right, so we must remember the fundamentals of this topic. Yes, so colleagues, what is the law of demand? Mr. Twalumba, Madam Juliet, what is the law of demand? Colleagues. You'll be asked theoretical questions where you need to explain this law. Mhm. And you already did micro, so you must remember this. The law of demand says there's an inverse relationship between price and quantity demanded, holding other things constant. Or you can say ceteris paribus. Are we okay with that? The law of demand says there's an inverse relationship between price and quantity demanded, ceteris paribus. Meaning, if price goes up, quantity demanded goes down. If price goes down, quantity demanded goes up. Okay. Is that okay, Mr. Columb and Madam Juliet? And the law of supply? There's a positive relationship between price and the quantity supplied, holding other things constant. So we've got this question here, right? You'll be given demand and supply functions. And these functions will have a lot of variables that affect them. Okay. Yes. So in this question, as you can see here, our demand function is given by this. Okay. Our supply function is given by this. They tell us where P is the average wholesale price of potatoes. Okay. So this P here represents the price of the potatoes. PW is the average wholesale price of wheat per meter. Y is income. PL is the average price of unskilled labor. R is the average annual rainfall in inches. Both QD and QS are in millions of meters of potatoes. All right. Yes. So they say the question is asking when quantity is expressed as a function of price, determine the demand for and supply of potatoes if the price PW equals 4, Y equals 7,500 billion, PL equals 8, and R equals 20 inches. So colleagues, here what you're supposed to do is just a matter of substitution. Okay, it's just a matter of substitution. You put these values into the demand and supply function. So let's get our papers. All right, let's start with the demand function. Where there's PW, put in 4. Where there's Y, put in 7,500. Then tell me what your demand function simplifies to. So we start with the demand function. Okay, so PW equals 4. So you substitute here PW for 4. Y equals 7,500. So you substitute here 7,500. Uh-huh. You can solve. Get your calculators and tell me what value you get. Tell me what value you get overall. Yes, have we got a value? Remember, for managerial economics, this is the best way to do it. Okay, you have to calculate also so that you get a feel of these questions. Have we found any value yet? And take note, there is a p, so that p should stay constant because there's no other p here, so nothing can add that p. 2,800 and wait, 2,830 minus 25p. Remember, there's a 25p here, so you don't have 'Yes, what's your new answer? minus 25p. Madam Juliet, what answer are you finding? Hmm. You do not have a candle. 12.5 times 4. 0.2 times 7. You must get 100 minus 25p. Negative 1450 plus 12.5 times 4 plus 0.2 times 7,500. That's supposed to give you 100. Any questions? Next is the supply function. PW is equal to 4. PL is equal to 8. And R equals 20. Let's get our value. Also calculate on my phone. So this negative 100 minus 25 times 4, that is 100, minus 25, 12.5 plus 200. So you're supposed to get negative 100 plus 75p. Any questions? That's our new supply equation. Any questions before we move further? Questions, queries? Okay, so the second part of the question, it says, where is that? Calculate if there's a surplus or shortage when P equals 1 kwacha 15 ngwe, 2 kwacha and tukwacha 50 ngwe. So we remember that when there is a surplus, quantity supplied is greater than quantity demanded. Okay, when there is a shortage, quantity demanded is greater than quantity supplied. Right? Then at equilibrium, quantity demanded equals quantity supplied. Okay. So here, what you need to do for your demand functions, we start with P equals, excuse me, P equals 1.5. So when quantity supplied is greater than quantity demanded, you have a surplus. When quantity demanded is greater than quantity supplied, you have a shortage. Okay. Then here, equilibrium. So we start when price equals 1.5 kwacha. Put this in your demand function. 100 minus 25p. So p we substitute it with 1.5. 100 minus 25 times 1.5. What do we get? Let's start, remember. 75. Hmm? So 100 minus 75, quantity demanded is 25. Since it's in millions of meters, so 25 million. Then quantity supplied equals 100, negative 100 plus 75p. This is negative 100 plus 75 times 1.5. What is 75 times 1.5? Let me just confirm. I'm just confirming. 1 1. Yes, 112.5 plus negative 100, 12.5. So here, quantity demanded, QD, is greater than quantity supplied. Quantity demanded is 25 million. It's greater than quantity supplied, which is 12.5 million. So here we have a shortage. Any questions? Okay. When price equals 2, so we substitute in our demand equation. 25 times 2, that is 50. 100 minus 50, that is 50. Now supply function, we substitute with 2. 75 times 2, that's 150. Negative 100 plus 150, you get 50. So here, quantity demanded equals quantity supplied. Equilibrium. So there's no surplus, there's no shortage. Any questions? Now we try when price equals 2.5. Okay. So what's 25 times 2.5? And 5 times 2.5? Are you there, Mr. Tolumba? So 100 minus 62.5, that is the quantity demanded. Okay, then 75 times 2.5, when we go into the supply function. Negative 100 plus 187.5, that should be 87.5. Yes. So here, what we see is quantity supplied is greater than quantity demanded. So here we have a surplus. Any questions? Also here we say surplus.